All right, guys, today we're going to do some division, polynomial division, including the remainder and factor theorems, and let's just hit it. Bad news on the first slide. First slide's all about long division. Not going to do much of this tomorrow, but a little bit. There's times you do have to do it, so I need to make sure you know what you're doing as you do it. So set it up like this. Set your divisor, the x plus 1, outside your division bar. Long division bar, x cubed plus 2x squared minus 5x minus 6. That goes inside. And really what you do is you look at the first term. I'm looking at the first term here, first term there, inside and outside. What does it take for x to become x cubed? What do you want to multiply it by? Would you multiply by x squared to get x cubed? So put x squared on the top. Once you put a number on the top of your division bar, you multiply by everything in the front, which would give me x cubed plus 1x squared. And you know when you do long division, you subtract right here. What I'm going to do instead is I'm going to change, when you subtract, you really add the opposite. So I'm going to change the signs and just add. That's always going to cancel. 2x squared minus 1x squared is just 1x squared. Bring down the 5x and do it again. Look at your first number out here, x. Look at it right here, x squared. What would you multiply x by to get x squared? X. So multiply everything in the front times x. You get x squared plus x. Again, I'm going to change the signs and add. What happens is those are gone. That's negative 6x minus 6. I'll bring the minus 6 down there. And I'm looking again. What does the x need to become negative 6x? It needs a minus 6. So multiply everything in the front to everything in the front times minus 6. I get negative 6x minus 6. And then what happens if I change those signs? Everything cancels, which means there's no remainder whatsoever. And so your solution or your quotient is x squared plus x minus 6. And that's what long division looks like. And thank goodness we don't have to do a whole lot of it. But there are times you have to do it. So you need to make sure that you can do long division, and that should be reviewed for you. The better kind of division is called synthetic division. You should have seen this in Algebra 2, but synthetic division is a quicker way of doing long division, but you can only do it when your divisor right here is a first degree binomial. If that's x has a 1 as an exponent, and it's a binomial. So here's how it works. I call this a little box. It's really like a backwards L. But what you do is you put the opposite of what's inside your divisor, or what makes your divisor 0 in your box. So I can put a 3 in the box. You then take all your coefficients from your dividend, 1, 2, negative 5, and negative 6, and list them on the side. Skip a line and draw a line. Take the first number, bring the 1 straight down here. Every time you bring a number down below the line, you multiply by what's in the box up here, the 3. 1 times 3 is 3. You put the 3 there. You add the two numbers together, that's 5. Again, every time you bring a number down to the bottom, you multiply by what's in the box. 3 times 5 is 15. You add. Every time you bring a number down, you multiply what's in the box. You add. That's 24. I always put a little circle around the 24 because that's my remainder. Now, that's all the work you have to do, but you gotta don't forget to write your answer down. Because we started with x cubed here and 1x there, I gotta figure out how many times x goes into x cubed, which is x squared. Or another way to look at it is, because we're doing synthetic, your quotient down here, your answer is always going to start 1 degree less than what you started with up here. So I start with x cubed. My quotient is going to start with 1x squared. The 5 represents the coefficient on my x, and the 10 is my constant. Now the 24 is the remainder, and the way we're going to write the remainder today is we're going to put the remainder on top of x minus 3, what our divisor was. So that's your quotient, and that took me a long time because I taught through it, but it's really quick, and as we go through these tomorrow, you're going to get so fast at that. And again, you should have seen that method in Algebra 2. It should be pretty familiar to you. All right, the remainder theorem is the first two theorems we're doing today, and it just says this. If you're going to substitute a number into f of x, then the result would be the same as the remainder if you did the division. So what we're going to do is we're going to, instead of substituting numbers in, we're actually going to do the synthetic division, check our remainder, that's going to be our answer. So that's what's called the remainder theorem, because the remainder is your answer. Okay, one example here, it says, given that this is our function, this big old thing right here, it says find f of 10. Now traditionally, we would take that 10 and plug it in for all the x's. This is going to be a monster though, because there's so many of them. Take quite a while to do actually. So what we're going to do instead is I'm going to put the 10 in the box. List out your coefficients. Now, one thing I have not said is this, and I need to say it because I'm not sure it's going to happen on the video. If you're missing an exponent, like here it goes x5, x4, x3, x2, x1, I'm not missing any. But if you're missing one of the exponents there, you need to put a 0 in your line of coefficients. Just make sure you do that. Okay, if we go with synthetic again, I'm bringing the 2 down. Every time you bring a number down, multiply what's in the box, add, multiply what's in the box, add, it's getting huge, multiply by what's in the box, add, oops, I'm already adding wrong, be careful there, be 1708, multiply by what's in the box, this is getting humongous, add, oh my goodness, multiply by what's in the box, luckily it's a 10, I can just add a 0 every time, and then I have a negative 8 to add to that, that would give me 170802, that's my remainder. Now, that's 170,802 is what I would get if I plugged in f of 10. So f of 10, if I plugged in the 10. F of 10 is 170,802. That was huge. All right, but that's all you do. If they ask you to find something like this, just put it in the box, do your synthetic division, whatever your remainder is, that's your answer. All right, determine whether 5 is a 0. A 0 means if it's a solution, means it's an x-intercept, also means you get a 0 for a remainder. So all I'm going to do is I'm going to take the 5, put it in the box, put my coefficients. This is a good one. I have x4. I don't have an x cubed, so put a 0. I got negative 26x squared. I don't have an x to the first power, so I put a 0. And I get a 25. I hope those zeros make sense to you. If you're missing an exponent, which I was missing 2 of them, you have to put a 0. So here it goes. Bring the 1 down to start. That's a 1. About put a 5. Multiply by 5. 1 times 5 is 5. Add, multiply, add, multiply, add, multiply, and look what I get right here. I get 0 for remainder. Because I got a 0 for remainder, that means it is a 0. So I put yes, it is a 0 for sure. All right, last slide here, the factor theorem. The way you can tell something is a factor of something is if you divide it, you get a remainder of 0. That's how you know. So when we go to division today, like the last problem, and I get a 0 for my remainder, that means that was a factor. Like 2 goes into 6 3 times with a remainder 0. That is why 2 is a factor of 6. So they're going to give me stuff like this. They're going to say, okay, decide or determine if x minus 1 is a factor of that big polynomial. So what I'm going to do is I'm going to do the division. If I get 0 for a remainder, that means, yes, it is a factor. So let's do the division. Put my box. Now I'm doing division, not plugging something in. I'm doing division, so I'm going to put a 1 in here. Remember, whatever makes it 0 or the opposite of what's inside your parentheses. Put your coefficients, 1, negative 2, negative 11, 12. And let's go and see if we get a 0 or not. So I'm bringing the 1 down like I always do. Multiply by what's in the box. 1 times 1. Add, multiply by what's in the box. Add, multiply, add, and look what I got. I got a 0, which means it is a factor. Yes, x minus 1 is a factor. Now the cool thing is if I wanted to, I could take what's left over, which is 1x squared minus x minus 12, and factor that like this, like we always do. And don't forget your x minus 1. So what I have down here, what I just did, those 3 right there, are all the factors of that. All right, just by knowing one of the factors, I can find the others. But yes, it is a factor. That lesson, this video, should have been a lot of reviews. It's been a while since you've done it probably in Algebra 2, but you should have done all of that in Algebra 2. So, and if you don't remember it, we'll work on it tomorrow like we always do. And I'll see you then.